Okay, this is 8.7, the variation of parameters method. It's a new way to solve for the YP, the trial solution or the particular solution, in case we can't use the annihilators. The variation of parameters method, the method of undetermined coefficients annihilators from last section that we covered in 8.3, has two limitations. It is only applicable to differential equations with constant coefficients. It can only be applied to differential equations whose non-homogeneous terms are capital F of x on the right side are of the form described in that section. For example, we could not use the method of undetermined coefficients to find the particular solution to the following differential equation. Look at this right here, x squared ln x. We talked about e to the x, we talked about sine x and cosine x and a combination and a polynomial, but nothing of natural log. So that is not applicable to the method that we use for the annihilators. We will consider the second order linear non-homogeneous differential equation of this format: y double prime plus a1y prime plus a2y equals capital F, where a1, a2 and capital F are continuous on an interval I. y1 and y2 are two linearly independent solutions to the associated homogeneous equation right here on the interval I. So the general solution to the homogeneous equation on I is yc. You do know yc, remember yc from previous sections. So the variation of parameters method gives you the following steps. We do have this equation right here. That's now the non-homogeneous differential equation of this setup. Your particular solution will be u1 times y1, that was mentioned early, plus y2, u2 times y2 and y2 that was mentioned early, in c1 and c2 right here in yc. This is y1 and y2 that was mentioned early. So the question is, to find the particular solution, we need to do the following. We know y1, we know y2 after we do the first steps solving for the homogeneous differential equation, but the idea, how do you find u1 and u2? You follow these steps and some algebra and you will be fine. These are the steps. This is kind of like a system together. As you can see, I'm grouped them with a different color. It's like two equations with two variables. y1 is known, y1 prime is known, y2 is known, y2 prime is known. y1 prime and y2 prime are not known. You could solve different ways, but the best way to save you some steps in algebra, we go back to the Cramer's rule. This is a linear system of equations for the unknowns u1 prime and u2 prime. Applying Cramer's rule, we get the following. These are the coefficients: y1, y1 prime, y2, y2 prime. And you know how to apply Cramer's rule. To solve for u1 prime, you replace the coefficients right here, y1, y1 prime, with 0 and f, as you could see. To solve for u2 prime, you replace those coefficients with 0 and f right there. So we usually take care of the denominator first, so we don't have to do it here and do it here again. We'll just finish it on the side and come back to these fractions, kind of like lengthy fractions but that's gonna save us some time to find these two first, which are the same. So in short, kind of lengthy to read here. On top, 0 times y2 prime as a determinant minus f times y2 will be written as minus y2 times f. Here, y1 times f minus, of course, 0. It's y1f. And this right here is the determinant, which is w, the Wronskian of y1 and y2, the way we do it. So that's how we find y1 prime and y2 prime. Of course, once you find y1 prime and y2 prime, this is our main focus. We integrate to find y1, u1, sorry if I said y1, and we integrate to find u1, u2. We go back and plug them in here. That's what I mean. So we integrate and we go back to the original equation. I'm gonna skip reading these and we'll see that practically through some examples. Here's an example. This is the same format that is given to me. Y double prime plus 4y prime plus 4y equals e to the power minus 2x ln x. X is greater than 0. That means I don't have to worry about absolute value while I'm integrating. First, consider the homogeneous differential equation. We first take care of y1 and y2. We make this homogeneous. We ignore this right here. The auxiliary function p of r is r to the second plus 4r plus 4. Factoring and solving, we get r equals minus 2 repeated 2 times. So we have y1 equals e to the power minus 2x, and y2 is x because it's repeated, e to the power minus 2x. Now yp is u1 y1, that's y1, u2 y2, and that's y2. But we need u1 and u2. We go back to this. In lengthy form, after you do the algebra, you put y1, u1 prime as u1 prime because we don't know it, u2, which is this right here, you put it there, and this is u2 prime. y1 prime, you find the derivative of this, minus 2 times. The derivative of this, which is a product rule, you put it down. And this right here has a capital F. That's our capital F up here. This right here has a 0. We keep it 0. And we use Kramer's rule. Of course, you could use other methods like elimination and so on. But to save some time on the video, I'm just gonna write and save you some time doing it one way, which is Kramer's rule. Taking care of the denominator, that's y1, y1 prime, y1, y1 prime, y2, y2 prime. That's what we have here. The determinant, we just multiply and we go back and subtract. Do the algebra, simplify. As you can see, I'm trying to save you some time. You could verify the steps. Instead of me reading the whole thing, you end up with e to the power minus 4x. So y1 prime, said y1, u1 prime is minus y2 times capital F over w that we just found, which is e to the power minus 4x. This is y2, this is capital F. Simplify between the e's, that's the same amount on top compared to this. They simplify. I end up with minus x ln x. u2 prime is y1f over w. Here's y1, here's f, here's w. Same idea, these cancel. After you combine these two, that's the same amount. You end up with Linux. I have u1 prime and I have u2 prime. I need u1 and u2. To integrate these, we need to do it by parts. I'm skipping reading the steps and doing it step by step, but I'm gonna display the work for you so you could pause and go through it yourself and practice. So we just integrate. Integrating both by parts and setting the integration constants to 0, we don't need the constants that comes from the integration. That's not gonna help us. We just need a particular solution, not too many particular solutions. A particular solution will do. These are the steps. This is minus x ln x right here. That's u1 prime. Integrating by parts gives me u1. Ln x right here is u2 prime. Integrating by parts, I get x ln x minus x. One more time, I'm not gonna read this. I'm displaying it for you so you can double check and practice. And of course, I'm trying to keep you in mind and save you some time. Instead of making a video of 45 minutes, if I could do it in half, like 22 minutes, that would be much better to watch, I think. So we go back to YP. U1 Y1 plus U2 Y2, we just plug in U1 Y1 U2 Y2 and we do the algebra and simplify. That's another format, you don't have to, but this is what I have. Now let's go back to display the general solution because we have everything now. The general solution is YC plus YP. We know what's YC, we know what's YP up here. Either format will do, it's fine. And I think that should do it for this section. It's a simple technique that you have to follow. Doing 5 problems is not gonna help much through the video, but it's the same process. Of course, you might end up with different type of calculations here and there. We used here integration by parts, so it depends on the problem. That should do it for now, and thank you for watching. I hope that it was helpful. Hit the like button if you do like it, subscribe, comment below, and if you like this video, hit the bell icon to be notified when I upload new ones. Until next time, peace. JaberTime. This is my second video tonight, and I'm working on the third and the fourth tonight. Thank you.